guys, this is Mrs. James and Mr. Jackson coming to you live for your homework tonight. Today we're going to be doing Jane's yard. So let's get started. Jane has a triangle yard with the dimensions 30 feet by 40 feet by 50 feet. So go ahead and write that in. And don't forget to put your units. So this is what we're starting with. Now, if she doubles each dimension for the house, how will it affect the perimeter? So we're going to go ahead and multiply each dimension by 2 because that's what it means to double. Okay, so to see how it's going to affect the perimeter, we're first going to find the perimeter of our original. That's 30 plus 40 plus 50, which will give me a perimeter of 120. And that's what the original triangular yard's dimensions. Now, if we go ahead and add the new ones, it's going to be 80 plus 60 plus 100, and that is going to give me 240. That's our new one. So as you can see, something happened with the perimeter. What happened was we multiplied each dimension by 2, and that affected the perimeter because the original times 2 will give you the new perimeter. So if we did 120 times 2, oops, 120 that gives us our new perimeter of 240 feet. So that's how it affected the perimeter. Now let's look at area. How will it affect the area? Area equals base times height divided by 2. So we're going to take the base of 30 times the height of 40. These are the original dimensions. And we're going to divide that by 2. So 30 times 40 which is 120 divided by 2. Which will give me 60. Oh, sorry. Sorry guys, that's 1200 divided by 2. My bad. Which gives me 600 feet squared. So now that we have the original, let's go back and find the new dimensions of the yard, of the triangular yard. So we have, let's go back and rewrite what are the new dimensions. You multiplied each one by 2, so that top one should be 60, or that one would, yeah, multiply that one's 80. The 30 times 2 is 60. And then the other one, 50 times 2 is 100. So we have those dimensions rewritten, and then let's go ahead and do 60 times the height of 80 divided by 2, and that's going to give me 4,800 divided by 2, which is 2,400 feet squared. So guys, for this area, instead of doubling, it actually quadrupled in area. So that's how it changed. Okay guys, that's 4 times the original.
Alright guys, we're still continuing on with the exploring measurements. And we went ahead and drew your little figure out there on the right. And how is the perimeter of the original rectangle affected when we proportionally, we're going to double the dimensions on each side. So we do 2 times 2 plus 2 times 2 plus 2 times 6 plus 2 times 6 will give you a total of 32 centimeters squared for our perimeter. Sorry, so we're talking about perimeter. It's not going to be square. It's just going to be 32 centimeters. And so if we triple the dimensions, we'll multiply each side by 3. So we'll multiply our width, which is 3 times 2 plus 3 times 2 plus 3 times 6 plus 3 times 6. Will equal 45 centimeters. And if we quadruple the dimensions, we get 4 times 2 plus 4 times 2 plus 4 times 6 will equal 64 centimeters. Then when it talks about halving the dimensions, if we have 2 for our width, we'll just go half of 2, which will be 1. And half of our length will be 3. So we have 1/2 times 2 equals 1. 1/2 times 6 equals 3. Which give us 1 plus 1 plus 3 plus 3, giving us a perimeter of 8 centimeters. And number 7 says, how is the area of the original rectangle affected when we proportionally, first we're going to double the dimensions. We're going to use the same lengths and widths as we use for our perimeter. So if we double the width and the area, the width and the length, we get a total of 48 centimeters squared for our area. We're going to do the same thing. We're going to triple our length. We're going to triple our width, which will give us 108 centimeters squared. We're also going to go ahead and quadruple our length and our width, which will give us 192 centimeters squared for our area. And if we halve those dimensions, half of 6 is going to be 3 times half of 2 is going to be 1, giving us an area of 3, which should make sense because our area is going to be smaller because we're halving those dimensions.
How does proportional change in the dimensions affect the perimeter of a figure? So we went ahead and gave y'all another example using the same rectangle. We used the original is 6 by 2, so to find the perimeter we added 6 plus 6 plus 2 plus 2 to get the perimeter of 16. And then we used a scale factor of 2 and changed the dimensions to 12 by 4. So we'll add 12 plus 12 plus 4 to get 32. So now we have to think to ourselves what happened when we did this. We use the scale factor of 2, and when you find the perimeter, you can multiply 16 times 2 to get the new perimeter of 32. So we'll just go ahead and write the perimeter is scale factor times the original. Times your original perimeter, actually, guys. How does the proportional change of the dimensions affect the area? Okay, guys, so now we're looking at what happens when we use area. So you can remember back, you need to do length times width. So you do 6 times 2, which gives you the area of 12 units squared right here on the original. And we use the scale factor of 2, you have 4 times 12, which gives you the area of 42 units squared. So what's happening here? When you use the area, you use the scale factor and you square it. And then you multiply that times the original. So we know the scale factor is 2. And when we square 2, that gives you 4. So 4 times 16. Hold on, that's not right. Yeah. Oh, was it not paused? Sorry guys. Let's rewind real quick. Actually, all you're doing is 12 times your scale factor squared. So that will give you 48 units squared. Sorry about that, guys. Now let's look at number 11. When both dimensions of a figure are changed using the same scale factor, is the change proportional or not proportional, and why? So when you use the same scale factor, it is proportional because you change the dimensions by the same scale factor. We'll see you guys tomorrow in class. Have a good night.